Welcome to Notes on Topic 6-1. This is the first topic of our first lesson of Topic 6. We are going to be talking about repeating decimals today. This topic is going to be revisiting percents eventually, so we just want to continue to talk about the relationship between decimals and percents. So right off the bat, we have a launch here, and they're asking us to use pictures, words, and a number to represent the quantity 2 out of 3 and 3 other ways. So go ahead and take it a shot with that one. Okay, so I said as a picture, I drew a circle, cut it up into 3 pieces, and shaded 2 out of those 3. Or you could have a bar or a box. Or then I also said that if I had 3 circles and did 2 out of 3, that could be another way to do it. Words, 2 divided by 3, and the number would be 2/3. Now the key concepts take up quite a bit of space on this page, but I felt that it was really important for you guys to see all of the steps here. So we have our vocabulary word of a repeating decimal. It states that a repeating decimal has a decimal expansion that repeats the same non-zero digit or block of digits without end. So what they are showing us here is that if you have the fraction 2/9, that needs to be rewritten as 2 divided by 9 right here. And they are clearly showing that this shows the pattern of 2, 2, 2. They are not just saying, okay, my decimal is going to go here, and I'm going to say, okay, that 9 goes into 22 times, then 18 to, okay, yeah, so my answer is 2/10 repeating. You have to clearly show that if you're dividing this out by hand, you have to show that there is a pattern. So that's why they're showing you this step and this step and this step. Now, ... means that it continues without end. So instead of putting 0.2 ... they are saying we're going to replace that with a bar that means 2 repeats without end. Then they also continue to show that if we have the fraction 2/11, if you rewrite that as 2 divided by 11, if you have the 1 and the 8 right here, you see the 1 and 8, then if you notice that the 1 shows up again, you can't stop there. You have to again clearly show that it goes 18, 18 as the continuing pattern. So I just want to have this on the side here, that if I had 635 thousandths repeating, how would you actually round this number to the nearest thousandth without the repeating bar? Would it be 635, or would it go up? So I write this out, it would be 635, and the next set of digits would be 635 again. So to the nearest thousandth, that 6 would make that 5 go up, so it would actually end up being 636 thousandths. Okay? On the next page, again, they're just repeating the definition of repeating decimal. That says a repeating decimal has a decimal expansion that repeats the same non-zero digit or block of digits without end. A repeating decimal is a rational number, which means that if it is a rational number, it can be written as a fraction. Okay, so that's revisiting topic 4. So what they are showing you here is that 2/10 repeating, 1800ths repeating, and 3 and 5400ths are all repeating decimals because they have the line that shows the pattern continues. Then we've got 2/10, 1800ths, and 3 and 5400ths. Not to give anything away, but that would mean that if this is not a repeating decimal, these guys, it's actually called a terminating decimal. So number 1, they're asking us to place each of these, or just circle which ones are repeating. I think this will be faster. So go ahead. I think this should be real quick. All right, so the 4 that I have circled there are considered repeating decimals. The other ones are all not repeating. And again, we're going to continue to go over what those are called in future videos. Example number 2 is again asking us to identify the repeating decimals. So go ahead and try that one. Okay, so the only one that is the answer here is choice number 1. It has the repeating bar. You can write repeating decimals with the ... but because in choice 3, you don't clearly see the pattern of 7272 ... we cannot assume that that is going to be a repeating decimal. It could go 7235 and then 72 again, but we don't know that. There's no way to be sure. And number two, we see a pattern, but it's not the same block of digits that are repeating. If it had been 404040, then that would have shown repeating digits, but that's not what it shows. Okay, example number 3 is asking us to write 7/15 as a decimal, and we would read this as 7 divided by 15, so we would set this up as 7 divided by 15. I'm just automatically putting the decimal points there and the zeros because I know that 7/15 is less than 1, so I know that I have to show this off with a decimal. So I'm going to stop and say to myself, 15 goes into 70, I think it's about 4 times, because 15 times 2 is 30, 30 times 2 is 60, so that's times 4, so 60, brings me to 10, bring down this 0 to get 100. 15 times 6 would give me 90, which again gives me 10. Then I add another 0, and I see that I have 100 again, which would give me 6 again. And I keep saying that now at this point it's clear to see that there is just going to be continual pattern. So my final answer will be 46 with just the 6 repeating. So be careful when you read this. 46 hundredths repeating sounds very similar to saying 46 hundredths with just the 6 repeating. Okay, so now number 4 is asking us to use long division to complete the table of decimal expansions. What do you notice about the expansions of the 9ths and 11ths? We are eventually going to see a pattern when we divide these out. So be patient with me. I know that it seems like we're going to be writing a lot, but just be patient. So we're going to take and convert 1/9. So I'm going to do 1 divided by 9. So 1 divided by 9. It's written out in that order. 9 goes into 10. There's no 0 here. 9 goes into 10 one time. So I go through and it's checked. I see I get 1 again. So I have to add another 0. 9 goes into 10 one time. Now, you cannot just leave the problem here. If somebody asks you to show the decimal expansion, you have to be able to clearly show the whole pattern. So 9 times 1, again, is 9. I'm finishing that and seeing that I get a 1 again. So clearly I see that I'm going to keep getting the pattern of 1. So my 9th is 1/10 repeating. We'll do the same thing with 2/9. So 2 divided by 9. 2 is not divisible by 9, so I put my 0. 20 divided by 9 goes in 2 times. It's going to give me 18. Again, bring down another 0. 2 times, 18. Okay, and again, I'm starting to see a pattern, so that's 2/10 repeating. And then some of you might have already seen the pattern, but let's just do this one more time to double check. If I was to take and do 3 divided by 9, 9 goes into 30, 3 times, which would be 27, 3 again, and I'm going to just keep seeing this pattern, then it's 3/10. So if I have a 3 in the, a 1/9, 1 in the numerator gave me 1/10 repeating, 2/9 gave me 2/10 repeating, 3/9 gave me 3/10 repeating, so I'm going to say that 4/9 gives me 4/10 repeating, 5/9 will give me 5/10 repeating. If you have a 9 in the denominator, then it's going to be a repeating decimal, and it's just the numerator repeating. Then for the 11ths, we're going to do a little bit more work here, not a ton. I'm going to do 1 divided by 11. So 1 does not divide by 11. 11 can't go into 10, so I have to put another 0 here. So now I'm looking at 100 divided by 11. 11 is going to go into 100 9 times. And that gives me 1. So then I have my 0. Bring down my 0, and I get 10. 11 does not go into 10, so again, I bring another 0 up here. Again, you cannot stop just yet. You have to clearly show that there is a pattern. So I have to bring down another 0. And 11 goes into 100 9 times. And you'll see here at this point that the pattern keeps going. So I get 9/100ths repeating. And yes, if to answer your burning question, you will be allowed to use a calculator, but you still should know how to change a fraction to a decimal without the use of a calculator. Now we're going to do 2 divided by 11. 11 goes into 22 times. No, that's a lie. 1 time. So that gives me 11. 20 minus 11 will give me 9. Bring down my 0. 11 goes into 90 8 times. 11 times 8 is 88. And that will give me 2. Bring down my 0. 11 goes into 20 1 time. 1 times 11, 11. Then I get the 9 again, bring down my other 0, and I can see that I have 90. Again, that goes in 8 times, 88, and I see that I'll get the 2 again. So, I get 18/100ths repeating. We could continue doing this out, but I'm just going to give away the secret that 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27/100ths. 4 times 9 is 36/100ths. 5 times 9 is 45. Okay, so be careful, that's 36/100ths. So if you have an 11 in the denominator, you will always have a repeating decimal. And when it's an 11, it's a multiple of 9 is what your decimal will be. So now, number 5 is saying to look at the decimal expansions below and make a conjecture. Conjecture is very similar to kind of a hypothesis or a theory. Make a conjecture about the decimal expansions of 3/7 and 6/7, and then prove or disprove your conjecture. So what they are showing us here is what 1/7, 2/7, 4/7, and 5/7 is equal to as a decimal. They are clearly showing that all of those fractions right now are repeating decimals, and they all tend to repeat after 6th place values. Okay? So what's missing is 3/7 and 6/7. Obviously, we wouldn't talk about 7/7 because that just equals 1 whole. So if you look carefully, it goes 1, 4, 2, 8, 5, 7. 2, 8, 5, 7, 1, 4. 5, 7, 1, 4, 2, 8. 7, 1, 4, 2, 8, 5. It's the same series of numbers, but the order's slightly being switched or kind of being cut off here. So if I was to keep this one going, it would 1, 4, 2, 8, 5, 7. This one would be 2, 8, 5, 7, 1, 4. So right now, I see 4, 2, 8, 5, 7, 1 right here. I see 4, 2, 8, 5, 7, 1 right here. Sorry for that interruption. So if I keep looking at this one too, 5, 7, 1, 4, 2, 8, we go 5, 7, 1, 4, 2, 8. And again, I would see 4, 2, 8, 5, 7, 1 right there. So the same series of numbers is repeating when I have a 7 in the denominator. So I'm going to say that both of these decimals, space that out a little bit better, both of these decimals repeat after 6 places. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So let's look here. It went 1, 4, 2, 8, 5, 7, and then this one picked up at 2, 8, 5, 7, 1. Well, the only digits that they're using are either a 1, 4, 2, 8, 5, or 7. To think about how things match up, 1/7 and 2/7, 3/7 would go right here in between 2/7 and 4/7. And if we think about how things are ordered, in the 10th place here, I have to have a number bigger than 3, or bigger than 2, but less than 5. So the only numbers in my string of numbers here that would work would be 4. So I know that 3/7 is going to be 4. If I look at 6/7, the first number in the 10th place has to be bigger than 7, and so I'm looking at 8, because that's from my list of numbers there. So then 8 would go here. So if I just look at the rest of the pattern, after the 4 in 1/7 came 2, 8, 5, 7, 1, and in 6/7 went 8, 5, 7, 1, 4, 2. So if I'm looking at the 8 right here, and one of the 7 numbers, 8 here, then goes 5, 7, 1, 4, 2. How I would prove this is if I picked up a calculator and I did 3 divided by 7, I get 4285714, 286. What's happening here is they are taking that the last digit, and they are rounding it up. So after the 8 goes 57 technically, but since this is the end of the screen, they're taking that 5, and because of the 7, it's now been rounded up to a 6. So you need to be very careful. The 3, anything with a 7 in the denominator is repeating decimal, but your calculators will appear to be lying to you. So you guys need to know that if there's a 7 in the denominator, you are dealing with a repeating decimal. So I checked that one out, and that one seems to be pretty good. And if I go 6 divided by 7, 857142857, notice that this one does appear to be repeating because the next number after the 1 would be a 4, which is not enough to make that go up. So be careful, this is repeating, so I'm putting a repeating bar over both of those. Okay, almost done. On the back, we have another key concept that now we have mixed numbers and decimals. So 2 1/3, they're representing with a picture, 2 full circles and 1/3 of another. 2 3/10 with the 3/10 repeating. We clearly see the 3, 3, 3, which shows the pattern, and then the dot, dot, dot. So number 6 says that a special effects artist uses miniatures to shoot a scene in which a jet flies through a tunnel. Will the plane fit through the tunnel? So they're giving us the tunnel as 8 7/10 inches, and the plane is 8 7/12 inches. So I need to change 7/12 to a decimal. So 7 divided by 12. Okay, 12 doesn't go into 7. That's going to give me 0, and I'm just going to add a couple zeros. 12 goes into 70 5 times. 12 times 7 gives me 60. 70 minus 60 will give me 10. Bring the other 0 down. 12 goes into 100 8 times. Let's just use the magic of television. I have this done. 12 times 8 is 96, which will now give me 4. Bring down the other 0. 12 goes into 43 times. Gives me 36. To give me 4. Well, I already had the 4. I'd have to go through this again, get the 0, and again I would get 3. So this is equivalent to 8 583 thousandths with the 3 repeating. So really, since we have 8 7/10 compared to 8 583 thousandths, I really only have to look at the number in the tenths place. And since the 5 is smaller than the 7, the plane will fit. And the answer is yes. 8 7/12 is less than 8 7/10. Okay. Number 7, very similar to number 6, so go ahead and give that one a shot. Okay, so just for my sanity, I'm writing down the cave of 6 4/10 inches, the sub of 6 5/12 inches, and I am now trying to change 5/12 to a decimal, and I see that they both go to a 4 in the tenths place. So for the cave, it would be 640. This one would be 641, which shows that the sub is bigger than the cave, so the submarine will not fit in the cave. Now, yes, you are going to be allowed to use a calculator, but you still should be able to show how to change a fraction to a decimal. Number 8 is asking us to calculate 1/3 of 100 and then calculate 33 hundredths of 100. What is the difference between the two results? Of means to multiply. That word of means to multiply. So 1/3 times 100 is going to be 100 divided by 3, which will give you 33 3/10 repeating. 33 hundredths of 100 is asking you to multiply those two numbers. So 100 times 33 hundredths is going to give me 0, 0, 3, 0 to hold the place value, 0, 0, 3. And notice you get 33. So the difference is 1/3 of 100 is a repeating decimal. And 33/100ths of 100 would not be a repeating decimal. So what they're just trying to show you here is that if you take a repeating decimal and you just kind of stop it and round it, your answer won't be entirely accurate. So it's better to leave your answers as fractions and multiply than it is to take a fraction, change it to a repeating decimal, and simplify. Okay, thanks for watching, guys. We will see you tomorrow.